in the last 5 or 6 years started to learn that in a valuable way is try not to make any statements. End everything with a question mark. And if they ask you a question, ask them a question back. But I've had people say to me that they perceive us and me as different than the other people. They're like, you're asking questions that nobody else has asked. And you're talking about things other people don't talk about. They're going to tell me what they want. And sometimes what they want is a good idea. And sometimes what they want is not a good idea. And then whether or not they take a drink out of the river or they piss on my foot is up to them. And at a certain point, I don't need a lot of piss on my foot. And that's not probably a good client for me. This would be a great client for my competitor.
Hi, and welcome to the Heat Pump Podcast. I'm Ed Smith.
And I'm Eric Fitz. We are co-founders of Amply Energy.
Today, we are very lucky to have Silas Hoeppner from Iowa. Silas was just on Bill Spohn and Eric Kaiser's Building HVAC Science Pod. It was episode 193, and it was awesome. We'd scheduled this with Silas a while back, so we're happy to welcome him onto another pod. We're going to do something a little different since Silas did an incredible job with Bill and Eric giving his backstory and how he got to where he is. So I highly recommend you go check that out. But given that, we'll do less time on Silas's background than we normally do, and then dig into some meaty technical stuff that we're excited to chat about with him. But to at least let folks know, if they don't go and listen to Bill's pod, Silas, give us a little bit of who you are, what you do, and then we'll go from there.
So I grew up in Northwest Iowa, up in a town called Spencer. And in Iowa is split in half by US Highway 20. Everything south of US 20 is Climate Zone 5. Everything north is Climate Zone 6. And I feel like there should be a little circle around Spencer that's like Climate Zone 12 or something. Because the wind blows 1,000 miles an hour and it's always like 400 below zero. And it's the worst and simultaneously the best. But my dad, my family, owns a very small insulation contracting business up there. And so I kind of got my start in the building performance and energy efficiency world, mostly being a gopher for him, dumping bags of insulation into the hopper and running him tools up to the attic and spending a long time in the back of a really hot trailer or a really cold trailer, depending on what time of year it was. And then I sort of fumbled my way through 4.5-year marketing degree at a small private university about an hour south of where I grew up, Buena Vista University in Storm Lake, Iowa, where I majored in football and minored in not doing much of my schoolwork and just barely skidded out of there by the skin of my teeth, if you will. But through that process, they have you do an internship. And I worked with a connection that Dad had with a small spray foam insulation specialty contractor down in central Iowa. And did an internship with those folks. And when I was ready to graduate and get out on my own, they had a job waiting for me as the sales manager there. And so I kind of got into immediately going from kind of 0 to 60 on the, importance of insulation and the building envelope and how buildings work. And through that, I just kind of found out that I was way more interested in how the buildings work and how we can solve problems and kind of the puzzle part of building performance more so than, the sales and marketing that I had gone to school for. In fact, I found that I was a really poor salesperson. I kind of was of the opinion that oh, hey, this one's better. So since it's better, you should pay more money for it. And when can I accept the check? And the builders were like, you should get out of my office. So it really just was kind of a mess, but you learn a lot from failure. And that's really the best way I can describe that first, probably 2 or 3 years was just a lot of failing and doing good enough to kind of keep the wheels rolling. But through that process, I met a couple of guys that were doing home energy ratings, and they were kind of trying to build their business and came to us and said, hey, you could really get a long way with your clients if you were to show them that it's not just a sales pitch. Hey, we could do some testing, find where the problem areas are. You could offer tailored solutions. And then after the fact, once you guys have done your work, we'll come back in and test it again and show them, the before and after. That way they don't take your word for it. Proof's in the pudding stuff. And that all sounded like genius stuff to me. It was all new to me too. I didn't even know that that was such a thing. And so I got to be working with those guys, and I eventually just said, guys, I just want to do what you're doing, because I have this one really cool, expensive tool, the spray foam. So if somebody calls me up and I can't solve their problem with spray foam, then just not very helpful. And at the time, they're just kind of like, yeah, you don't want to work here. This is just glorified data entry, and you're so smart, and you're a great salesperson. I'm like, I don't know about any of those things, so I want to come there. And long story short, I ended up working there about a year later and learned a lot from those folks. And I think where I really lucked out was, in addition to the traditional home energy rating, blower door, duct blaster, 95 AFUE, 0.30 solar heat gain, whatever it was, all the nitty gritty stuff that you learn about home energy ratings and energy efficiency. These guys had a kind of a baked in partnership and had learned a lot from the folks at NCI, National Comfort Institute. And HVAC was a complete mystery, and I didn't know anything about heating and cooling. In fact, I had purchased my first house in 2006, and I lived there for about a year before I figured out that there is a furnace filter that should be replaced sometimes. And I found that out because the furnace quit working. So, gosh, So we had the opportunity early on to do some utility-sponsored audits in a town called Palo over in eastern Iowa. And those folks were really great to work with. They had experienced a flood that had destroyed something like 300 of the 310 homes in town. We went over there and audited probably 200 of them and kind of helped them put stuff back together in an energy efficient, high performance way as best we could given the circumstances. So that's kind of how I got into all of this. And then from there, the industry just kept basically opening up windows of opportunity of like, hey, there's this missing piece in HVAC. There's this missing piece in thermal envelopes. There's this missing piece in building performance. And since about 2008, I've just been going into houses, testing things. So, long story short, they're working with those folks. We were a third-party independent home energy rating company, building performance consulting. Most of our clients were home builders, and we were doing a lot of that early Energy Star program. So I got an opportunity to just do a bunch of testing and seeing how this stuff is built in the field and then measuring it. And when you do that, you get to see a lot of like other people's mistakes and what works good, what doesn't. And from there, it kind of progressed into system design. Before I ever designed a system, I had the benefit of being able to go through and look at how not to do it, essentially. Go test a bunch of high static, low airflow, problematic buildings, look around and see what not to do later. So a lot of that stuff was kind of like learned in the field and supplemented, late nights reading buildingscience.com, reading Energy Vanguard's blog, just so much great stuff out there, and great for a guy who's kind of out of school and at the time early on didn't have a family, and coming home to a 700 square foot apartment is like, I could, watch TV or I could read about building science. And so here we are.
And so you're at Modern Heating and Air, and what is your role at Modern Heating and Air?
Yeah, so it's a unique kind of a utility, lot of hats position. We're a small company, family owned, locally owned. They started in 2010 with just a couple of partners doing all the work, doing everything, and brought it up from there. And today we're something like 15 to 20 employees, 6 or 7 full-time service technicians, 3 full-time installation crews, and then some office folks kind of overseeing business. And my role there is, I guess I'm sort of the resident building performance guy. And so I have some input on anything from like, hey, we're doing this installation, it's going to be goofy, we got a weird transition, like how do we cut down the restriction on the airflow, how do we make static pressure work on the steel, load calculation, sizing, design, anything new construction we do, which is pretty limited, do all the design on paper on purpose for those things before we get started. I do some traditional sales. We have a specialized salesperson on staff, and he does, the heavy lifting on the, hey, somebody called in, wants to replace a furnace, wants to replace an air conditioner, whatever it looks like. And then he'll go out to those calls and kind of filter out, Is this a traditional sales call? Is this a problem solving, kind of advanced, don't want to step in it, technical sales call? But yeah, so, that's kind of the business, the way we do it. And primarily existing homes, we do some maintenance and some repair and replacement on some small commercial buildings like storefront stuff. But really would like to focus mostly on residential.
So I know on LinkedIn, it's Space Archaeologist, which you did a great job explaining that for Bill. And like, having heard this, I translate that to, you love thorny building science problems that orient around comfort and can handle almost anything that touches comfort. A lot of what you guys do is HVAC, but it's sort of the puzzle of comfort for existing residential homes. Like, you love cracking that in all its nuance and trickiness.
I grew up in a home where we celebrated Harrison Ford's birthday with cake and ice cream. And Indiana Jones was kind of the movie I grew up on. I mean, I've probably seen Indiana Jones 1,050 times. And I really love, Indiana Jones, Sherlock Holmes, procedural, whatever. And you can really apply all that in reality to the house. And I got really interested in the house. But I think, interestingly, as I've kind of gotten older and, some more gray, I found that as much fun as it is to do the code cracking, puzzle solving stuff with the house, it's a way bigger challenge for me to interact with the client. And so I'm a huge, massive introvert. And it's really hard for me, in a big group of folks to sort of get out there and get a conversation going. But I do pretty well when I'm one-on-one with the client or the client and their spouse or partner. I'm at the kitchen table and I can start nerding out and digging in and asking questions. It was just learning that I need to ask those questions and presume that they may not be truthful with their answers. And sometimes that's not even on purpose. I think there's this natural, defense mechanism where like, hey, you're a guy who's going to take some of my money and then you're going to theoretically give me something. So I need to hide certain things from you and keep those things close to the vest. And being able to suss that stuff out and get them to share those things and get them really into a place where they're comfortable being emotional is, I think, really important in this line of work, because what is more emotional than your biggest investment in your entire life, where you spend most of your time, where you raise your family, where your cat buddy jumps up in your lap while you're trying to do a podcast. I kind of believe that your home is a sanctuary. It's where you can go to recharge. Being a person whose sort of social battery depletes very quickly, like, this is my safe place to come and just be like, okay, whew, I can chill out. After I get off this recording with you guys, I'm just going to lay down for a while. This is going to take it out of me. But the point being, like, you can do a really good job of that if you feel physically comfortable, if you're not worried about, is my house harming me in some way? Do I have mold? Is there some toxic something or other? Something smells weird. I got to call somebody and get this thing fixed. There's water leaking off of this. There's something dripping off of that. Billy's bedroom in the northwest corner is super uncomfortable. He's sleeping in our room, and that's a major problem. He needs to get the hell out of here, So all those things, like, we tend, and then I'm speaking, when I say we, I guess I mean me. I tended early in my career for people to tell me, like, hey, I want insulation because I'm uncomfortable. And I didn't hear because I'm uncomfortable. I heard I want insulation. And then I get out my calculator and I want to do all the testing and the measuring and find out how much insulation, what kind. And like, there's value in all that. But if it doesn't jive with what the customer perceives or thinks they want, it's a waste of time, really. So,
Silas, it was great. You hit on a couple of things I just wanted to comment on. First, I love the Indiana Jones analogy. I think that's actually works really well, because you're going in and exploring in a home and you find things. You also run into like technical booby traps. You also run into like booby traps with the customer, like what you were saying, like sometimes like people either a lot of time unintentionally are giving you misinformation because they're guarded and they don't have a relationship with you yet. And you've got to navigate all of these different elements, the technical side and this very non-technical, human emotional communication side. And I, I'm definitely a technical guy. I've got a technical background. And I remember, I had an early sales role many years ago. And I think you mentioned something about this just in your comments a few minutes ago. But like, I remember thinking, man, if I can just share all the technical details, the end client, they're going to, if I tell them all the performance numbers and like everything is great, like they're just going to love it and they're going to buy it and it's going to be great. Turns out that doesn't work at all. You've got to tell a story. It has to connect with them emotionally. You can have the best product, the most amazing solution, but if you can't communicate it, if it doesn't resonate with that homeowner, you've got nothing. And
that's about as well as I think I could have ever put it. You can be technically sound, you can know all the things about buildings, and you can lay out a perfect plan, or whatever. But if that client perceives that there's something either that they believe that isn't true or vice versa, it's just that you're dead in the water. And unfortunately, that kind of describes a lot of my earlier career. It was just a lot of testing, a lot of report writing, a lot of, how can I write this in a way that I can try to convey 5 years of experience learning all this really cool stuff and these neat tools and all this cool testing to somebody who's has absolutely really no background or education in how buildings work. It's interesting. I was working for a third-party energy consultant a few years back, and they were based in Eastern Iowa. And so I was out there at like a children's camp, summer camp sort of a thing. And the guy that was kind of the manager of that facility was from, Scandinavia, somewhere in Europe. And when I went over there, they were having some trouble with some things. That's why I was there. I was kind of doing an initial walkthrough to see, are we a good fit to help you figure out these problems with your building? And they had this mechanical room with 1,000 giant water heaters in it. They're all natural draft. And I said something like, hey, I know you got other problems, but we should really like make sure that this isn't an issue. And he goes, oh yeah, because of, the potential for combustion and carbon monoxide safety and backdrafting. And then he just rattled off all this stuff. I'm like, do you need a job? I could use your help. How do you know those things? And he's like, I'm from Europe. And just kind of looked at me like, why wouldn't I know that? I was like, okay. Like, interesting. So there's different culture. There's a different understanding.
Interesting.
There sometimes. So, but when you're talking to clients and all this cool stuff you want to share, like I have this immediate thing where I want to evangelize, like, oh, I learned static pressure. Let's talk about static pressure. Your filter drop is way out of bounds. And then like 20 seconds in, your client's eyes are just rolling in the back of their head. And they're like, what are you selling? So even though it's really good information, it informs us a lot about what the problems are and what things we could do to solve it. It is like brain Novocaine to the client, and they just check out. Like, you think, well, if I can sound really smart, surely they'll pick me over the other guy, but the other guy was $200 less. So sorry, when you follow up a month later, you haven't heard from anybody, and they're like, yeah, we decided to go the other way.
Right. Yeah, especially when those eyes glaze over, all the client is hearing is like the Charlie Brown, like, wah, 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 and all they heard from the other guy was price is lower. So that's what's stuck in their brain, and you've just missed an opportunity. And yeah.
And to their credit, the other guy talked about stuff the client cared about. Oh, this is high efficiency equipment. It's super quiet.
Yeah.
We're going to make you so comfortable. Like, can they actually deliver on those things? Like, yeah, sometimes by like dumb luck. Absolutely. Like the standard scope of work is the standard scope of work because it works pretty good some of the time, and often enough that, at least in our marketplace, where people aren't getting into massive trouble, and they do a really good job of advertising on TV and the radio and getting their logo out there. They do a really, really good job of calling people back, getting stuff on the schedule. Everything's professional and they're participating in all the right community events. But they just don't know design, and they don't know airflow, and they don't know performance, and they don't know buildings. So other than that, it's top notch. And I'm not saying that to be pejorative. It just is the nature of where we're at, I think, in the industry right now. Like that's the more people that I talk to, like when we're interviewing folks to come be part of our team, tell us about, in your schooling experience, how much time do you spend on system design? Like, well, what do you mean by that? Like load calcs, like manual J? Like, yeah, that's part of it. And they're like, well, I mean, the professor pulled up my RightSoft one day in our class, and we drew in some rectangles and 100,000 5-ton. It's just like that. That's the intro and the exit of the entire conversation about design. And then it's like, we talk about static pressure for a day. You got to have enough static. You want to make sure you have enough static for airflow. And it's like, okay, tell me more about that. How did they present that to you? And it's like, it's a hiccup in the process in most cases. And that, again, not to be pejorative, it just is what it is. We go just about anywhere and it's that case. And so, I got lucky, really, and fortunate that I was able to learn all those things without having the burden of understanding how to go diagnose a widget in a furnace that was broken. Frankly, if you put me in that situation today, I'd go in and I know some stuff because I talked to some people, but you put me in a basement with a system and a bunch of sheet metal and you're going to come back in 3 days, I'm going to be bled out on the floor and nothing done. That's not my skill set. That's not my thing. So that I didn't have to learn all those things and I could really focus on the design and the airflow and the performance and how it all relates to the building was simultaneously kind of an advantage and a bit of a Achilles heel.
How do you find the middle ground today? Like, it sounds like you're still doing the right analysis to get the right design for the homeowner. And then how do you communicate it to a homeowner such that it meets them where they're at, but you also show that you're different? That given the average in the industry, you guys are doing things that are differentiated and highly technical. How do you land that point and without getting the glaze over face, and so that they recognize like, this is a higher value contractor I'm talking to right now?
I spent so much time in my career being like annoyed and almost cynical about like, if people just knew what I knew, they would do what I do. And kind of back to what Eric was saying is like, if you kind of blow them out of the water with technical stuff, they'll have no choice but to say, yeah, that's the thing. And your stuff and you're smart and good and you're better than the other guy, and for a long time, the bar was pretty low. I'd go to an estimate, for a system or equipment replacement and people are like, well, the other guy didn't even bring a tape measure. So the fact that you're going to spend some time measuring some stuff, that's really cool. And that just kind of like, I kind of feel naked without a lot of the data and the information. If I don't know what the airflow and the static pressure of the existing system is, like I just feel, I wish I knew those things. And so I really want to I want to do that, like, hey, let me test your system. And I've had people like just flat out deny, like, no, we don't want you drilling any holes in our system. That's crazy. We had 3 other bids and nobody else even talked about this stuff. So it started out with something that I felt like I had to like apologize for the fact that I wanted to help them better because they just didn't know any better. And so I spent a lot of time just word vomiting on people about like, well, you should really do this and you should really do that. And it's best practice to have a load calc. And well, you should really have a blower door here. And gosh, we need some static pressure and some airflow. And they're like, the other guy was here for 22 minutes and emailed me a price later that day. And we have been talking for 32 minutes and you've done nothing. You're still in my entryway talking about, BTUs and whatever else. And like, that is just not the way to go. I think if there's anything that I've learned, and I think I'm going to pause and say, this is going to be a very personal thing for the person who's doing this work based on your personality. I'm an introvert. I'm a data guy. I'm a tool guy. I like to have information so that I can make wise decisions, all that stuff. But that's going to be, not everybody's that way. And it's going to be different. Your clients are going to be different. Maybe that's even more important, is that you need to be able to talk to the client in a way that matches their personality and kind of what their expectations look like, but without giving up, yourself and your message. So the way I learned to deal with that, and really have learned that in the last 5 or 6 years, started to learn that in a valuable way, is try not to make any statements. End everything with a question mark. And if they ask you a question, ask them a question back. It's really hard. If you're not used to that, if you kind of came up and you're trying to be the old dog with a new trick, which I kind of feel like sometimes, it's hard. But I've had people say to me that they perceive us and me as different than the other people. They're like, you're asking questions that nobody else has asked. And you're talking about things other people don't talk about. And I feel like they're saying that in a way that you're actually trying to understand what it is I'm looking for, not just tell me what you want to do to my house. And since I've started doing that, I don't have to convince anyone of anything. They're going to tell me what they want. And sometimes what they want is a good idea. And sometimes what they want is not a good idea. And if I ask the right questions in the right order and enough, and I pry and I dig and I do those things, they're leading themselves to the water. And then whether or not they take a drink out of the river or they piss on my foot is up to them. And at a certain point, I don't need a lot of piss on my foot. And that's not probably a good client for me. This would be a great client for my competitor. So that's kind of what I've learned is if you can just make a good connection with the customer, ask lots of really good questions about what it is they think they want, and then lead them down that path with more questions. Well, you tell me that you want efficiency. Tell me what that means to you, because that word efficiency is a proxy for literally every superlative you can think of. I want my house to be efficient. Oh, okay. So if we go 97% instead of 95, if we go 3.5 COP instead of 3.2, if we go 17 instead of 16, that's what you're looking for. Like, I don't know what any of that means. I just want my house to be efficient. Oh, okay. How do you find your utility bills? You just keep asking these questions and get them to actually tell you what they mean. And pretty soon you find out that efficient to them means value for the dollar spent, and Billy's bedroom's uncomfortable and we don't like that. Has nothing to do with BTUs in, BTUs out and energy in. It has everything to do with, does the thing do the things we want it to do? But if you don't ask that question, you just hear efficiency and you start selling on AFUE and COP and SEER, you're just like the other guy right out of the brochure.
I love that approach. I'm curious to get like a more specific example. So like what happens, you're in a house, you measure static pressure. It's like really clear that filter box it's way too small. Like you got static pressure issues all over the place. How do you then communicate that to a customer in a way that's accessible and easy for them to grasp?
So I'm going to challenge you on that to begin with, because that premise is good. But I used to do block load calculations and airflow testing and static pressure testing, at least at the equipment level, sometimes even out into the rooms with flow hoods and that kind of stuff. Sometimes block load supplemented with blower door. And that's been a really interesting hot topic here lately. Can you do a good load calc without a blower door and vice versa? And I try really hard because I really, really want to do those things. I try really hard not to do it until somebody's willing to pay me for it. Now, I am the self-proclaimed OG of you shall have load calcs. You shall have a blower door. You shall do it per the code. But I just didn't experience much success with that, at least not proportionally to the time that I was investing in doing those things. And frankly, in my marketplace, there's like a handful of us that I can think of that I would feel comfortable in actually doing a load calculation and trusting the results. And lots of people that talk about load calcs, there's lots of load calc theater, like it's become really popular in my marketplace to say, well, we do everything the right way. We're going to do some load calcs, and and then it's like go around and measure the windows, tell the customer you're going to get their footprint and their square footage off of the tax assessor page, and then we'll run all the math, and tell you what you need. Oh, you need a 3.8 ton, but I tell you, they don't make a 3.8 ton, so we're going to round you up to a 4, so you got plenty. It's like the actual load in the house is 2.5. I'm like, sounds good, but I try really hard not to give those things away because there's a lot of value in that, especially in our marketplace where there aren't a lot of people that can really do that in a meaningful way. And I don't feel like consulting should be free. And I feel like if you ask the right questions and get to the bottom of what the call is about, that they're going to eventually say, well, is there some way to know how to do these things? Like, yeah, I'm glad you asked that. I've actually built my career on those things. That is my craft. And it just so happens that I am working for this, traditional, very conscientious, high level of craftsmanship HVAC contractor. And so that's how we demonstrate that we're different, is by asking those questions. And so now, it's all that being said, because that's not even your question, I tend to do that.
But I love when someone asks a question and the answer is, that's not a good question, and let me tell you why. But Eric, that was a great answer, Silas. Like, that was actually a fantastic answer to Eric's question, but keep going.
I hate confrontation. I have to, because of just the nature of who I am, I have to remind myself that there are people that are successful because they are able to be like, I'm going to challenge you. I'm not going to just agree with that to be agreeable. That is not in my nature. I was the kind of teacher's pet, mama's boy, very timid person growing up. And then I was able to grow into football, and that was a bit of a combat sport for me. And I was able to start kind of releasing some of that built up tension. But through that whole growth process from back then until today, I've found that the customer isn't always right. And you can tactfully bring them along the road to show them how much they don't know, without just saying like, that's not how this works. You don't know anything. Let me tell you how smart I am and how much I know that you don't know, because that's not going to work. It doesn't work very often anyway. Ask me how I know. So going back to that is, if you're asking enough questions and you're digging to find what the pain is, they're eventually going to ask you, like, how do we solve for these things? Because there's some way you can know how to make all these invisible things that you're talking about visible. You're talking about airflow and how you can't see that. And you're talking about heat and the movement of how heat moves, and you can't see that. And you're talking about humidity and moisture and how you can't see that. It's like we're chasing ghosts. Of course, if you can see the moisture, then you know it's a problem. Usually, if you're not running the water out of the tap and you can see the liquid water, it's like, oh, we got a big problem here. But that, I think, is the point, is if you can ask enough of those questions and dig into that pain enough, they're going to eventually ask you, like, what is the salve for this wound? What is the medicine for this ailment? And then you can say, well, based on what you're telling me, these are your issues. You could either replace your filter rack with a bigger one, and immediately that leads to like, wait a minute. So the filter that I've had here in my house for 20 years, you're saying is part of the problem, and your solution to that is to put a thicker one in? That doesn't make any sense to me. It's going to be harder to blow air through a thicker filter. Well, I'm glad you brought that up. Would it surprise you to know that if you were to stretch out that filter that's 4 or 5 inches deep and compare that to the one you bought that's a 1-inch pleat, that it would be way bigger? Like, which one of those would you rather try to breathe through if you wrapped it around your head? Like, it's going to be a lot easier. There's a lot more surface area. So then you can start to do your explaining because they invited you to do it. But if you walk in the door and say you got an undersized filter rack, they're going to hear, I sell filter racks.
Right.
And that may or may not hit. That's a hit or miss deal.
That was so well explained. I was just about to ask you, can you give us an example? And then you just did it.
I'm going to butt in here a minute. There's so much stuff. Like, if you cruise through social media and you're hanging out in Facebook or whatever and looking at all the groups that are in performance and whatever, and even just like HVAC school or wherever, where there's, HVAC contractors with all different levels of experience, and almost to a person, if you talk to somebody who understands that airflow is a deal and it can be a problem, they will tell you ductwork is undersized, period. Almost everywhere you go, without exception, we don't have enough return and the ductwork's undersized. And I would say that a lot of those people are probably right. I've moved to using the term underdesigned because sometimes the duct sizing is maybe part of the problem, but there's some other stuff going on. I mean, just from a nerdy technical thing, like an elbow is whatever it is, 100 equivalent length of duct or whatever. So if you can straighten that out, whatever, that's really great. You can also make that elbow a lot bigger, and then there's a lot less equivalent length because there's less friction and all the good thing, all the nerdy stuff. So sometimes it's undersized, sometimes it's underdesigned. It's almost always underdesigned. But what I've found, at least in our marketplace, is that usually the duct work matches the house pretty well. And if you match up properly sized equipment to the house, it usually is pretty compatible with the duct system, except for the 1-inch pleated filter, hypoallergen purple 7000 MERV 800 FPR,
Yeah.
whatever it is that somebody bought because they thought, well, this one's more money, so it's better. I feel a certain way because I bought this filter. And look at what they're up against. You go into Home Depot or Lowe's or wherever, your local hardware store, and there's like 17 aisles of filters, and there's every brand and color, and high efficiency is a really classic one, so it's good. Very few of them are talking about performance airflow, and nobody knows to ask those things. It fits in the slot, it's got to be the right one. So you're up against it from the beginning. And if you can I feel like in my marketplace, if you could just go door to door and right size or correctly design the filtration scenario, you could probably improve measured performance on these systems by about 50%. Just by getting the right airflow. And then that allows you to do the things that the thing should be doing to begin with. It allows you to dial in the combustion. It allows you to charge the thing properly and get the right SHR and pull the right humidity. And so even more importantly, I think, at least in my market and my anecdotal experiences, than the ductwork is the filter. It's a pandemic.
That gets me so excited because, it is daunting to come into a house and to think about, oh my gosh, the ductwork is under-designed. I like that phrase. And I think I need to go in. I got to go in the attic. I got to find new transitions. There's a whole bunch of like sheet metal work I need to do. And it's going to be labor intensive. I got to find all the spots. It's going to be super complicated. It's going to be really hard to sell a homeowner. But it turns out like a huge percentage of the challenges are just right there, right next to the equipment. It's the filter. Like, go there first. And it's an amazing opportunity. It's like not a whole lot of work, and you can have huge transformation for the homeowner for, Jimmy's room, actually gets air to it for the first time.
Yeah, absolutely. It's crazy sometimes, at a certain point, working for one of the third-party energy consultants that I worked for in the past, we came up with a product service called an HVAC optimization, where we're not licensed HVAC contractors. We're not selling. We're installing furnaces, air conditioners, heat pumps, equipment of any kind, mini splits, nothing. But we're going to take what you already have and we're going to make it work as good as it possibly can. And we find that enough, and honestly, the houses we were doing that in were mostly 5 years old or less. And around here, that meant they were probably HERS rated, Energy Star rated, probably between a 40 and a 50 HERS score. And those folks are calling and saying like, hey, we got uncomfortable spots in our house. We're worried about our air quality. Our furnace is super noisy. There's literal trash in our ducts, just all the dumb stuff that you wish wasn't true, kind of about the everyday spec building market. And a lot of times we could walk in and you could ask a really brief handful of questions, which rooms are the least comfortable, what's going on, tell me what bothers you. And you just be like, hey, when you walk into the mechanical room in the basement in the wintertime, is that like the most comfortable room? Feels like a tropical beach? And they're like, yeah. They're like, oh, there's a real high likelihood that you have high static pressure, low airflow, and that's probably a big portion of that is the air filter. And then you'd walk in and there'd be a 1-inch 16 by 20, 10 by 20 drop on a 60 or 70,000 BTU furnace. And you're like, yeah, well, I could do a bunch of testing here, but I kind of know what's going to happen. I've got 150 of these under my belt in the last 6 months. So, and then you do, and you put the pretty report together with the, this is in the red and this is in the yellow. And show them all the stuff, kind of do the dog and pony show a little bit. It's like my friend Mark Parley is a building performance consultant, and he stole, and he'll love this that I said this, he stole this from Joe Stiebrick, who says, if you don't do the show, you can't get the dough. It just so happens that the show isn't really like snake oil or nonsense. It's, I got to turn the static pressure and this airflow and these CFM and these BTUs into something that's meaningful to the client. And if I can show them, hey, come down here, listen to this furnace run, and it's doing what it's doing. And then you just pull the filter out and all of a sudden you can hear this whoosh of air. And their complaint was like, Billy's bedroom in the northwest corner doesn't get any airflow. Well, here you go. And we can fix that. And that's kind of the conversation you have to have, not, we know all this technical stuff. So
make the invisible visible, make the complicated accessible and understandable. It's, yeah. Yep.
There's been some, oh, go ahead.
That was the, I don't know, the dollar answer for the 5-cent question, I think. But, I think that's kind of the heart of it.
It's been awesome because all this stuff ties together. Like, this is basically what you've been coaching folks on is how to weave great building science into a great sales process. When too often there's sales processes with no building science or hollow building science, and building science is like really bad at sales. And I think you've done an awesome job of articulating how those two can meet in the middle in that phrase. Yeah, you can't get the dough without having the show. Or this is teed up for me like, this is the Heat Pump Podcast. Talking a bunch about airflow, talking about sales process. I'd love to combine some of these and get into heat pumps. And so one question for me is, what role does airflow volume play in equipment performance? And why is it especially important to understand when switching from fuel fired to heat pumps? And then if I could tack on something that, then how do you sell that insight? But maybe we go in that order.
In my career, I have the ability, like I said, to sort of like partition off some of the traditional installation and, repair and maintenance stuff, because I'm able to rely on my team to be good at those things. And then I can really focus and specialize on some of the stuff, in my opinion, that is at the base layer of the pyramid. If we're talking about a Maslow's hierarchy of heat pumps, I would argue that your airflow is going to be on that bottom layer, and the ability to move the correct airflow, because, one of the lessons we learned here in central Iowa, we're climate zone 5 down here. Our design temperature is 0 degrees in the winter and it's 90 degrees in the summer. And maybe this is a good example of, humidity is an issue here, but I can't rattle off to you what the incidental wet bulb is for my location. That's off the top of my head. I would have to go look. So humidity is an issue. We have corn sweat is what somebody said online there. We have high humidity here, but it's for like 2.5, 3 months. It's not a constant barrage for 7 months of the year like they have in Florida or coastal Carolina or somewhere like that. So we have to be able to handle it, and those things are important, but it's a small enough part of the year where a lot of people can kind of get by making some mistakes. All that to say, there is this, it's kind of a long held belief that if you're replacing an 80,000 or 100,000 BTU furnace, gas fuel fired furnace, that you just got to have a 5 or a 6 ton geothermal, a 5 ton air source heat pump, because that's 60,000 BTUs, and you've got, we're taking out 80. So we got 80,000 BTU furnace might have 11 or 1200 CFM, and a 5 ton heat pump's going to be 1800 to 2200, depending on what you're trying to do. Those two things don't go together. And the other spoiler alert is the duct system and the filter and all the things that came with that 80,000 or 100,000 BTU furnace in the house are already under designed for that equipment at 1200 CFM. And then you've got guys out there saying, but the geothermal is going to save you so much money and it's so comfortable, and whatever all the sales pitch is. And then they go execute the system that has half the return inlet opportunities that it probably needs. It has under designed duct system. Sometimes the filter situation there is baked in and not a bad deal, but really the only reason those were absolute abject failures is because we removed the external coil from the equation. A lot of those systems got packaged geothermal heat pumps or packaged air handlers with, electric resistance heat, and coil is built into that system. So somehow magically, and I still don't understand this to this day, there's an engineer somewhere who can tell me why furnace that has an external coil is rated at 1/2 inch and maybe measured out to 8/10 or 1 inch static. But then we take the exact same coil that we piled on that furnace and we put it inside the cabinet. And all of a sudden I have an inch of external static or 8/10 of an inch of external static to work with. And we just pretend that coil doesn't exist. What's the difference there? Is it the blower? Is it what's the magic sauce there? That might be a good question for somebody who's a lot smarter than me, but you take that external coil out of the situation, you've got a geothermal or an air handler blower that can handle all kinds of static. And that's really the only reason the thing doesn't just fail and freeze up all the time. It's loud, it's obnoxious, and it can cause a whole bunch of other problems, but it worked good enough. It kept the thermostat satisfied. At least in our market, that's what we see a lot of. Turns out, if you go through the trouble of learning more about the house, understanding what the people want, doing the load calculations, doing the airflow diagnostics, it usually comes out like, oh, hey, this house that had an 80,000 or 100,000 BTU furnace and a 4-ton air conditioner actually needs if it were going to be a fuel fired system, it'd be a 60K 2.5. That's 1,000 CFM. And I could probably do a pretty good job on this house with a 2 or a 3-ton heat pump and a right size backup, whether that's fuel fired or whether that's some auxiliary resistance, electric resistance heat, or whatever that is. We can do a pretty good job with that. And now all of a sudden I don't have to worry about a bunch of duct mods, maybe stuff I can't even get to anyway. We're a basement market here, lots of living space in basements, and everything's covered up with drywall. Truth be told, ripping out drywall and replacing ductwork really isn't hard, but it's emotional. People don't want to destroy their house and rip down drywall and deal with the dust and the whatever. I mean, you have it all wrapped up and put back together in a week, but it's just cringe. Like, ugh, that sounds awful. My house is put together. I don't want to unbuild my house so that I have better ductwork. Who wants to buy that?
Right.
So
and it's always scary too as a contractor, because sometimes you find stuff, you open up walls and you find stuff that you didn't want to be responsible for finding. So it's scary from that standpoint with you.
I used to watch a lot of the the DIY TV, and I can't remember the name of the show now. Might have been Trading Places or something or whatever it was, but those folks, I think they were up in Canada, and that woman would come up with a plan and they'd start ripping stuff, and she'd be like, oh man, who could have ever known that there was going to be framing and plumbing and electrical in this wall? Now we're up to triple your budget because we found a plumbing stack in your wall. It's like, you didn't think there was going to be plumbing in this house? Get serious. But it's a good point. Like, you get kind of laser focused on like, oh boy, if I could just make this a 24x8 instead of an 18x8, boy, we'd be in business. And like, oh, then there's stuff in the way and you can't do that. You got to get creative. So
great answer. And that, I think, tees up nicely. Sometimes the right answer is going to be a heat pump that seems scarily small. So I know you and I have talked about this a bit before, but there's a ton of contractors who are uncomfortable with equipment sizing. You also teed up like manual J theater. So I'm interested. Talk to us about like why some are uncomfortable with it and why it's not as scary as they should think it is, and how to avoid manual J theater to get to like the best answers, especially in the context of heat pump retrofits.
Rules of thumb, a lot of the stuff that somebody did the math a long time ago and then said, most of the time, if you do this thing, this many square feet, this many tons, you're going to be in good shape. And they were probably pretty good. Like, 50 years ago, some of these rules of thumb made sense because there wasn't a lot of building insulation. Buildings weren't very airtight, at least not on purpose. And, those things kind of made sense. But since then, we've been on this like crusade of, every couple of years, we need more R value in the attic and we need a higher level of duct tightness and we need a higher level of air tightness. I'm not going to say those are bad things, but I think we don't understand maybe as an industry what that's doing to the building. The average house in Iowa that gets built new, which I would consider to be a standard operating spec home, I would consider to be a low load home. These houses are 1.5 to 3 ACH 50. They have high levels of thermal insulation, R45, R50 in the attics, R15 to R23 in the walls, just depending. High performance windows, it's pretty common here for a standard vinyl window to be less than 0.30 solar heat gain and U value. High efficiency equipment, all this stuff. And you have this really big, house, 4,000 square feet of floor area. And it's really hard to split up a right sized piece of equipment, the airflow that's required for a properly sized piece of equipment, and actually handle all of that volume and all that footage. And, it may be just as hard to do that as it is to take the oversized piece of equipment and make sure you get rid of enough air with the ductwork and all those things. So we have this, kind of continual approach at more R value, better building, more efficiency. And then on the equipment side, it's very similar. We have higher SEER, higher SEER, higher SEER. And what you see as that goes along is like your SHR just keeps climbing. A lot of this equipment, when I run a load calc around here, we're running into the building needs a 0.83 to a 0.87 piece of equipment. And a lot of the equipment, when you model it out, is like 0.91, 0.92 under, about as little airflow as you can blow through the coil without it freezing over. And it's just kind of like, eventually these things just don't match. And you get into marketplaces where there's a lot of humidity. And now you're talking about like, well, this is just a piece of cooling equipment. Now I need a whole separate other piece of equipment to handle the dehum load. And so now you're purchasing another piece of equipment, you're installing it, you're maintaining it, you're repairing it, and you're replacing it in 5, 6, 10 years. And it's just kind of like, the old R22 oversized system that had half the airflow it was supposed to have was running at like 0.5 SHR and took all the humidity out. And the utility bill was $104 a year more. Like, maybe I'd just take that extra $104 a year in utilities and be comfortable and remove the humidity and not have mold. And, all these advancements and all these things that should be making the industry better. And all of a sudden the stuff gets harder. The tolerances are more difficult. It's more difficult to install and commission these systems. The tolerances, the windows of how much airflow you can blow through the thing is smaller. Like everything is harder. So that contractor that had been doing it for 40 or 50 years and was good at it is all of a sudden in a completely different world. And so all that to say, that guy's used to 600 square feet per ton or whatever it is. And now he's got some Yahoo on a computer who does blower doors for a living telling him, well, you should have a 2-ton on this 4,000 square foot house. And he's like, we'd have done 5-ton all day long on this thing. So it's a major culture shock. Like, I don't blame that guy for being concerned, because he's the one who's going to get the call on August 412th when it's 1,000 degrees outside and the customer's like, it won't get to 62. And you're like, oh, Jesus, like, I get it. I get where he's coming from, but like, the whole world changed around that guy, in 40 years overnight, sort of. And it's a scary leap, but those of us who have been doing this for 15 years put in the equipment that Manuel J said we should put in, and then we go back and we ask some questions, we learn some stuff, and like, the furnace still only runs half the time. The properly sized furnace only runs half the time. All that to say, at least in my marketplace, you don't have to size your heat pump on the heating load. In fact, if you do, you're probably overdoing it, and you probably don't have the ductwork to do it. And then you're spending the customer's money renovating ductwork that may not even matter to what they want to get out of their system. So here we have the benefit, size the heat pump to the cooling load, follow the old version of Manual S. I mean, for those that are familiar, it's almost like the folks over at ACA are a bunch of smart people who know what they're doing. And that's, the more you do that, and then you ask questions and you track run times, you track utility consumption, you don't get complaints, and you find like, hey, not only is this not scary, but like I'm still kind of oversizing it because I didn't follow the thing in the book that seemed even scarier. Take full credit for the insulation inside the cavity. Take full credit for the overhangs on the windows. Take full credit for the window treatments. And don't overdo all of the little electrical gizmos and gadgets and be like, well, there's 5,000 BTUs of electrical equipment in this room. Like, yeah, but 90% of that doesn't run at the same time. And a lot of it's for an hour at a time. And it's not at 5 p.m. when you have peak solar, you got to just it's kind of the leap of faith a little bit. You just do it and then you monitor it.
And what I hear you saying is that homes continue to evolve over the last many years in a more rapid pace and in ways that, like, the home that was built in the 1950s, the windows may have been changed out twice, given the life of a window being around 30 years since that home was built. And like, holy cow, a window from when that home was built to a window, that's NFRC rated from 10 years ago, very, very big difference. But like with all of these different changes in the building, it's too much to try to you can't pen and paper this. You need to observe what's going on in the home and use some software to actually run the numbers and trust the process. And then you're going to have success. Is that right?
It is. So there's this really popular, and this is probably something you guys don't know about. I'm going to tell you for the first time, there's a really popular theme right now in providing tools to contractors to be able to do all of the really important best practice stuff faster, so that it's not a burden on the business to be able to do things like load calculations. So it turns out,
tell us more about that.
There's businesses out there that have literally developed digital tools that will scan a building and tell you how many BTUs of load you have. Did you guys know that?
That sounds super cool. We should link to that in the show notes.
I highly recommend getting on those people's coattails ASAP.
Okay, good advice.
But, and in the same vein, like folks like NCI, folks over at the Energy Conservatory with their TrueFlow grid and all these things. Actually, I think where I saw that is from the Energy Conservatory said, I'm going to screw it up, but it's like doing it right faster, easier, whatever it is. Like, that we need to do that. That's part of the industry needs to develop those things so that we can arrive at those things better. But I would still argue that just because those things are faster for us to do shouldn't necessarily mean that we give them away. And I don't mean to gatekeep. It's not my thing like, oh, I know how to do this, but I'm not going to do it unless you pay me. That's not really the motivation. The motivation is using that kind of carrot, if you will, to get the customer to come along that journey and understand the importance and the impact of those things. Because there's going to eventually be somebody in your marketplace doing load calc theater. We learned that here 10 years ago. The guys would say, load calcs? You don't need load calcs. We've been doing this for 100 years and, we've got a 4.8 star rating on Google and da-da-da. And now they're saying load calcs. Absolutely. You got to do a load calc and we're going to take care of that for you. And guess what? No charge to you. And 12 minutes later, the customer gets the entire load calc that they paid for. And it's nonsense and it's sales and it's to convince the client that they've done something they didn't do. And I think even to be truthful, that isn't necessarily fraudulent behavior. It's like they believe whatever it is they're doing has value.
Right.
And that's problematic as well, but maybe a little bit better news than just leaping to like everybody's trying to rip off everybody. They think they're doing something that's providing value, but it's just confirming their bias of oversized equipment anyway.
That last point about, they're actually not only are the person that's doing the load calc theater, they're potentially shooting themselves in the foot from like a sales perspective. They're also shooting themselves in the foot from customer callback, all kinds of service issues down the road. So like it's in the salesperson's, the designer's best interest. So they actually understand what is a proper solution. And then the proper solution is actually delivered to the homeowner. So everybody's happy. You got a profitable job. you get a happy homeowner who's going to then refer you to other clients, and it all goes well. And like the thing you mentioned about like feeling naked if you didn't have some kind of tools, because like I understand that feeling, because if you are not doing some kind of measurement, whether that's load calculations, maybe you're doing things like blower door and static pressure testing. If you're not doing those measurements, you are just guessing, and guessing is terrifying in a game of $15,000 projects. This is somebody's home that they raise their family in. Like, holy cow, like don't mess with that. Well, guess.
So like if you have a conscience and you understand some of these things, and then you're basically asked like, yeah, I don't want to do any of that. Just, give us your best guess. Listen, in 15 years of testing houses in one marketplace, like I can guess with the best of them, but I still feel itchy doing it. I just don't like to do it. And to that point, back to that argument of like, can you do an accurate load calculation without a blower door? And my argument or my statement to that is yes, it's possible to do. Does your average practitioner have enough experience and enough knowledge about the building itself to be able to do that? I don't know. Or have they read through diligently, Manual J and looked at all the criteria of what does average mean? How do we translate that into each individual marketplace? What is an average house here for me compared to what an average house is to some of my friends who do this work in other marketplaces? I'm frequently blown away by how leaky some of the average houses are out in other places. Like, so, and I don't know why. My hunch is that for whatever reason, we just did some stuff different here when a lot of these houses in the 60s, 70s, and 80s were built. It's not uncommon for me to run into houses that can darn near pass, a 2018 or whatever energy code as is without having to do anything based on air infiltration around here. But then I hear folks from like Ohio or, somewhere else in the Midwest, and they're like, yeah, this 1,200 square foot ranch has, 4,700 CFM50. I was like, did they only build 3 walls? Like what? How did that happen? So in some ways, this marketplace can be pretty easy compared to like somebody like Jenry Garcia that's down in Florida, or some of the talented folks down in Louisiana who, a little bit of ACH 50 goes a long way. And like, how in the hell are we going to dehum this building, and how are we going to keep it from not growing mold? Like, we have some margin for error on those things here. That said, we also have 2 feet of snow sometimes. So there's different challenges in different marketplaces, but it just seems like the more experience that you can get, the better you're going to be at guessing, but nobody's ever going to be perfect. And how much of that risk do you really want to take on? I borrowed this from Nate Adams and his book, The Comfort Book. A lot of my sales approach comes from that. And then I've augmented with, the last 15 years of my experience and my personality. The popular saying was like, you could be plus or minus 70% based on the blower door. Well, that's not true here. Very, very rarely. And when I walk up to a house that's plus or minus 70% of the blower door, I can eyeball it. It's an 1860s, 3.5 story crazy thing, and it's 12,000 CFM50. If I pull up to the 1940s built 1.5 story house, it's going to be 4,500 CFM50. And I know where to go knock out 1,000 and make the thing work. Not everybody has that experience. And the folks that do are going to rely on it too often. They're going to lead themselves astray 1 or 2 times. And that's when you get into the big problem where there's litigation and you're writing checks to fix stuff. And why take that responsibility on your own shoulders if you can walk the client down the path of like, listen, I can guess with the best of them. I have a lot of experience here. It could be true that your house is this or that. How comfortable are you with me guessing that? And just ask them. That's how you can have integrity in this situation. I feel like contracting 1.0 was really about going in and saying, I'm the best. I'm an expert. I know everything. Put all your eggs in my basket so that they'll pick you instead of the other guy. And that's a flawed process because the other guy is saying the same stuff. And then basically it boils down to like which guy matches your personality better. It's a terrible interview
Yeah.
process. Google reviews are bogus. Who has less technical ability to properly evaluate a good HVAC install than somebody who just had a system put in yesterday? Oh, that was great. The guys showed up on time. They didn't swear in my house. They didn't burn the carpet. They showed up when they said they would. They left when they said. They charged me the amount they said. The heat worked when they left. It blew hot air. 5 stars. Like, what happens in 14 days or 14 months or, whatever? Like,
Yeah.
And
What a
you
good
can
point.
feel pretty darn good on the day that they replace your equipment or even 6 months after they replace your equipment. They don't know what it could have been. How good could this house have been had they gone through some of this process? So there's a lot of satisfied customers giving 5-star reviews that got a lot less than they paid for it.
Yep.
That is a great point. It's also nice because you wove in there, the advice on asking the customer a question that lets them decide, which is kind of where this conversation started. After you introed, you talk a lot about your Socratic method to sales and asking questions as opposed to just bombarding people with expertise, which feels like a nice kind of place to wrap, kind of hitting on a topic that we started with. We've talked a bunch. I guess my final question would just be, Silas, for knowing who our target audience is, people who are trying to build heat pump businesses, trying to do heat pumps the right way. Any parting words of wisdom? You already shared a bunch, but anything else?
I think that there's a popular belief that the conversation around heat pumps is financial. Now, I will temper that with there's a lot of folks that are environmentally motivated with heat pumps. I have the unique perspective that it doesn't matter why my customer may or may not want a heat pump, but I can probably do the best job and I can probably solve more of their problems and I can probably build a better system if I have a heat pump. It's better at all the stuff. It's better at load matching. Essentially, like if you want to talk to a gas furnace guy and you're like, is a 2-stage furnace or a 1-stage furnace better? Is a modulating furnace or a 2-stage furnace better? They're always going to tell you, well, the 2-stage is better than the 1-stage. The modulating is better than the 2-stage, but they cost more money. Well, the heat pump's another stage of heat. So whether you're doing an all-electric system or whether you're doing a dual fuel, that heat pump is just allowing you to do all the things that a gas furnace would do if it could, if it was small enough. There's a lot of 30,000 BTU furnaces out there that most people don't even know exist. And some of those are 2-stage and it'll go down to like 22,000 BTUs of input. But you're also blowing like 9 CFM through that thing. Otherwise, you're going to have, like a 10-degree heat rise. And the math gets wonky all of a sudden. So you have this low load building that's got a bunch of square footage, and then you got this tiny little gas furnace that you're trying to split up, 400 CFM across 4,000 square feet. Like it does, the math doesn't math. God, wouldn't it be nice if there was a piece of equipment that needed more air and could deliver fewer BTUs at a time, or even, modulate or stage based on how many BTUs the house is actually gaining or losing. Like the heat pump can do all that stuff better than the gas furnace. Don't be scared of it. I just got a call on Saturday. My dad was at an estimate on Saturday for insulation for a little old lady, Social Security. She was affected by the terrible floods that they had up there this last summer. Unprecedented, like historic floods up there. It was devastating. But she had baseboard electric heat in an all-electric house built in the 70s, peak oil embargo construction up there. And a contractor came in and said, well, you have ductwork in your attic for your air conditioner. Let's just put an air handler with a 10 kilowatt electric heat. And, we'll go from electric resistance at the baseboard to electric resistance forced air in the attic. And she's lived there for 100 years and her utility bill peaked out at $300 ever. And last month she had an $800 utility bill. And she made it very clear, $800 does not fit in my fixed budget. Even if it did, there's a lot of other things that I'd rather do with $800. And she was exasperated. Like, she was just like, what's going on? The contractor that she had paid to do the work lacked the proper credentialing so that she couldn't even use the grant funding for the flood recovery to pay his bill. And so she had paid him half. He had installed the air handler and the heat kit, and he was going to install a split air conditioner. And I'm like, well, just with the limited information that I have in this 20-minute phone conversation, she should take that 13-SEER air conditioner and swap it with a 14-SEER matching heat pump. Like, it's not the best case scenario for climate zone 6, but you're going to take that 800 to 500 right now. All other things remaining equal. It's a no-brainer. And so Dad reached out to the HVAC contractor and said, hey, what about a heat pump? And they go, we steer clear of those up here. Nothing but problems with heat pumps. And I'm thinking to myself, how can we be here in 2025? We're supposed to have flying cars.
Yeah, where's my hoverboard?
Yeah.
And we've got folks in the marketplace that are telling people that $800 utility bill is going to be a better situation than they might have some trouble with the heat pump that they could install. I mean, in fairness, they'd have to run different low voltage wiring. So that was really frustrating. And I said, hey, if this guy wants any coaching, any help, any whatever, like, tell him to give me a call. I'll do it for free. I'll drive 200 miles up there and help, because this is her one chance to get this right for at least the next 15 years. And frankly, it kind of sounds like this is the last HVAC decision she's going to make on this house. So it's an opportunity missed, and it's low hanging fruit. It's the easiest bar to jump over. And it's kind of like, looks like a mountain. So anyway, that was the thing that, you know, you run into that stuff and you're just like, how can we be here?
Silas, this has just been fantastic. I feel like I know you so much better as a person. I think you're incredible. You have so much knowledge to share, and it's just been so much fun to hear your story, to hear various anecdotes, your advice. Really appreciate your time. And yeah, thank you so much for coming on.
Yeah. Thank you very much. I really appreciate what you guys are doing. The more of this information that can get out, I feel like the fewer opportunities that we're going to have with that bad situation that I just described, you know. And I guess the best thing that I can say is, like, take it from me. I've made the mistakes. I've screwed up the stuff. You don't have to do those things. You don't have to screw up those things. Like, learn from my mistakes that I've made in 15, 20 years and listen to all the really good information out there. You know, the stuff that you guys are doing, the Energy Conservatory, Nate Adams, the Comfort Book, like all these really great resources where we can skip past the nonsense and just get down to, like, hey, this is legitimate. These are things we can be doing today. And it's not easy. I don't want to say that it's easy, but it's attainable. And we have, as an industry, we have the skills. It's almost just like we have to get comfortable with trusting ourselves that we have these skills, and we have to learn a little bit more, and we have to do these things so that we don't kind of step in it. You know, we've talked kind of quite a bit about, you know, the great heat pump revolt. I think Steve Rogers from Energy Conservatory said the great heat pump revolt of 2025 or whatever it is, because there's probably a lot of bad stuff going on. I don't think we're that far away. If we can just understand some of these things with the airflow, the static pressure in the house, that really, in a way that other people put it to me, it's not rocket surgery. You just have to try, and you have to, you know, be open to it. So
love that.
Rocket surgery made
Great
easy.
place.
Yeah.
Rocket surgery made easy.
Rocket surgery
definitely.
for dummies.
That's our next blog post. Silas, thank you so much for joining us on the Heat Pump Podcast.
Thanks so much. I had a blast. You guys are awesome.
Thanks. Thanks for listening to the Heat Pump Podcast. It is a production of Amply Energy. And just a reminder that the opinions voiced were those of our guests or us, depending on who was talking. If you like what you've heard and haven't subscribed, please subscribe in your favorite podcast platform. We'd love to hear from you, so feel free to reach out. You can reach us once again at hello@amply.energy. No.com, just .energy. Thanks a lot.